These are the notes for geometry, Thursday, 9:29, and we're going to work on finishing 1-6 today. And this problem I asked you to do kind of at the end, and we'll kind of go over it right now. And it says Terry has 19 feet of tape to mark off an area in the classroom where the students may read. Which of these shapes has a perimeter or circumference that would use most or all of the tape? And so really for this one, you should find all of the solutions and then kind of see which one uses most or all of the tape. So for letter A, if it's a square that is 5 feet by 5 feet, the area, or excuse me, the perimeter for that is just 4 times 5. Perimeter is 4 times 5, so 20. You can't use A because you only have 19 feet of tape. Then for letter B, it's a circle with a radius of 3. And to find the circumference of that, it would be 2 pi r, so 2 times pi times 3, and that would be 6 pi. That's about 18.85 feet. And so that's close, but we really have to check everything to see if that's going to be kind of the best one for us to use. Now, letter C is a right triangle with each leg of 6 feet. So this one you had to remember something. And if you look at your 11th grade formula sheet that's in the front of your notebook, you'll see the Pythagorean theorem there, a squared plus b squared equals c squared. And if each leg is 6, those are a and b, and this is c that's missing. So first, before you can find the perimeter, you have to find that missing side. And so a squared plus b squared equals c squared. 6 squared plus 6 squared equals c squared. This is 36 plus 36 is c squared. I'll push this up a little bit so it's easier for you to see, and then I'll slide it down in a minute. This is 72 is equal to c squared. And so then to get c, we take the square root of 72, and that's equal to c. This is approximately 8.49. For our value of C. So C is approximately 8.49. Now I'll slide that back down a little bit, and now we can find the perimeter for that one, which is adding 6 plus 6 plus 8.49, and that's approximately 20.49 feet. Oops, I didn't write feet way up there. So that one is too long as well. For letter D, we're doing the rectangular one, and so it has, it's 8 feet by 3 feet. The perimeter there, 2 times 8 plus 2 times 3, and so that's 16 plus 6, or 22 feet. So once we've looked at all of the options, we can then confidently say that B is the correct answer for that one. So hopefully you have an understanding of that problem as we look at it. This just shows all of those worked out as well. So I will make that available to you, and it will be on the YOLA site as time goes on here. And then we're going to skip that problem. And so I'm just going to put an X through it. And then we're going to work on this one. You'll notice I have a note to myself, really, that there's a student handout for this one. And Ms. Eckhoff has this handout available to her for you to use. And so I'll ask that you pause this so that she can hand that out to you. And then I'm going to start going over this one. It says find the perimeter and area of the pentagon ABCDE. And with those coordinates that are given, A is 0, 4, B is 4, 0, C is 3, negative 4, D is negative 3, negative 4, and E is negative 3, 1. So the first thing we're going to do is use the distance formula to find all of the missing lengths of sides as we look at this handout. And this is a pretty involved problem, so I gave you a big sheet of paper with plenty of room on it for you to find the different things. So I'm going to go through the very first one of the lengths with you, and then I'll give you some time to try and calculate a couple of them, and then I'll show you the answers as we go. So we're going to do perimeter first, and if you'll notice, 1, 2, 3, 4, 5, segment DE is just 5 units long. DC, we can also count 1, 2, 3, 4, 5, 6. So that one is just 6 centimeters, or excuse me, units long, not necessarily centimeters. And then we're going to find together these other ones. AB is the one that I'm going to have you find together with me. Just a reminder, the distance formula, the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared, and it's the square root of that. And so for AB, if we call A x1 and y1, and at B we call these x2 and y2, then you'll find that for this one, um, the length from A to B is the square root of x2, which is 4, and it's this 4, minus x1, which is 0, in parentheses squared, plus parentheses y2, which is 0, minus y1, which is 4, in parentheses squared. And so then for this one, we get the square root of 4 minus 0 is 4. 4 squared is 16. Now 0 minus 4 is negative 4, but remember when we square negative 4 times negative 4 is positive 16. And so then that's the square root of 32. And that is approximately 5.7. Take a minute right now, pause this recording, and so I'll write 5.7 right there. Find the length from B to C and the length from E to A. So I'll ask that you pause this. I'm going to count down from 5, and then I'm going to show you those answers as we go, and then you'll find the perimeter. So 5, 4, 3, 2, 1. And so BC should have turned out to be 4.1. And EA should have turned out to be 4.2. 4.2. That means that the perimeter of polygon A, B, C, D, E is P equals 4.2 plus 5.7 plus 4.1 plus 5 plus 6. And so the perimeter is equal to 25 units. I'm going to show some things how to find BC and EA. So I'll get rid of some of these boxes. If you had a little trouble knowing exactly what to do here, is all of those lengths found by using the distance formula. And then here's that answer for the perimeter. So especially if you want to check BC, some work is right there for that. If you want to check EA, some work for that one is right there as well. And so I'll leave that for you. That's the perimeter. Now we also have to find for this one the area. Oh, excuse me. So for this one, I'm gonna go to another copy of this slide, and hopefully you're using your space wisely. If you need to, you can kind of fold up the paper a little bit so that you can kind of have a little more space for this first one. We're going to divide this pentagon into two triangles and a rectangle, and I think you'll find it's very easy then to find the area. And so the two triangles are going to be this green triangle. I'm going to trace that like that. This red triangle. And then I'll also trace this yellow rectangle right there. So that yellow rectangle as well. So we need to find the areas of all of those parts. And I am going to kind of go through that a little bit by using this slide that I have. And you can see the book authors have divided that up the same way. And so the next thing we're going to do, we've divided the pentagon into two um, triangles and a rectangle, and now we're going to find the area of the triangles. And triangle 1 is going to be that top one that I called kind of that green triangle. If you'll look at that one now, I'm going to label some things in black. Remember, this side is 6, so the base of that is 6. The height here is 3. The area of a triangle is 1/2 base times height, so we're going to take 1/2 times 6 times 3. So here's the work for that, and the area of that green triangle turns out to be 9. And I'll let you kind of look at that as well. Then we're going to find the area of the red triangle. And again, we can count boxes to find the base and the height. I'm going to call the base this side 1, 2, 3, 4, 5. That base is 5 long. It's that side of that rectangle we used before. I'm going to say that the height is 1. So to find the area of the red triangle, I'm going to take 1/2 base times height, 1/2 5 times 1, and 1/2 5 times 1 is 5/2, or 2.5. So the area of the red triangle is 2.5. Then we're going to find the area of the rectangle. We already remember from our previous work that that has the dimensions of 6 by 5. The area of a rectangle is length times width. 6 times 5 is 30. So the area of that rectangle is 30. Now, we were to find the area of the whole pentagon, and so we're going to add those answers, and we get 41.5 square units. So the perimeter is about 25 units. The area is 41.5 square units. Now, the next thing, and here's all that problem worked out. It'll be on my Yola site as you look at that. Now, the next thing I'd like you to do is take some time, and on that handout, you are finding the perimeter of this quadrilateral, and you're using the distance formula as you go. I'll ask that you pause this, give yourself some time to find that using the distance formula, and then I'll reveal the answer to you. So I'll count down again, 5, 4, 3, 2, 1. And hopefully you've had some time to work that, and the answer for that is letter A. Now, that is this lesson. I am going to say that now you're going to write your summary. Don't forget to include your level of understanding at the end of the lesson. And writing your 3 questions. Also, if you're in first, second, or seventh hour and you didn't write your summary and questions for section 1.5, I'll ask that you add that as well. Make sure you wrote summary and questions for section 1-5. And so I'll leave that little note with you. And that should conclude this lesson 1-6. Just a reminder that homework 6 is due on Friday. If you will be at the festival, or excuse me, if you'll be gone to the Renaissance Festival on Friday or gone for any field trips, then you will turn it in on Monday, and I'll give you your work that you're missing on Monday.